all I have is the next one, which I have no clue what I'm doing.
Fantastic.
And then I can take my.
All right, people. Here we go. Okay. So, does anybody know what the quadratic formula is?
X equals A, B plus plus B, B plus plus C something else.
No.
Okay, Dylan.
Okay, right?
We all don't know the memorizations and everything, but okay.
Yeah, Amy's drilled that in my head.
Well, good.
Some of us have bad memorization. Okay.
Yeah. So quadratic formula, what Dylan said in rocket speed. Okay. So this is just another way of solving a quadratic. So we solve quadratics by factoring. That was the very first thing that we learned how to do. And then we learned how to square root both sides, get rid of the squared. That's the second way. Third way was completing the square. Fourth way is quadratic formula. So there's always like restrictions with all of them. So factoring only works if you can actually have two numbers that multiply to C and add to B. Sometimes they're not factorable, which we found. Square root method only works if you just have a squared term and not a next term. And then completing the square is just like a pain in the butt. Quadratic formula is foolproof. Like it gets out every single answer, no matter what. You can use it every single time to solve a quadratic. So this is like a masterpiece, basically. So we're going to actually prove where this actually comes from. So instead of just having it memorized up in your noggin, which we all need to have this memorized for the test, we can see where this actually comes from using the completing the square. And we all know this is like to the tune of Pop Goes Weasel. If you want to like see it to yourself, right? Like looking at your child. Dylan, do you know the song for it, or do you just have it memorized? You don't want to sing?
I don't sing.
Gosh.
I think Green wants to hear you sing.
I think Hank wants to
I don't know how. I think someone should be singing. Cause I do.
Yeah. I'm not a good singer, so I'm not gonna. Yeah, do that to you. Okay. So we're going to try to prove this. So basically, to prove, we're going to start with my general equation. So starting with ax squared plus bx plus c equals 0. So to prove that, I need to basically manipulate this equation to get down to the quadratic formula. So somebody did this back in the day to actually figure out this fraction piece. And we're going to do it right now. You don't have to regurgitate this for the test. This is just for funsies, so you don't need to even write it down if you don't want to. Okay. So if I'm given this, we are going to prove the quadratic formula using completing the square. What is the first step always when completing the square? What? Okay. Dylan, do you know? Bailey, do you know?
Yeah, let me want to say something though.
What's the first thing you do when completing the square? First step. We want to get to a square root part, but not.
like to be over 2 squared.
Okay, so we need to find the c value. That's one piece, but we're not set up correctly yet to do that.
Is to get into intercept form or like an inner form?
Yeah, that's a goal. We want to get into standard form. Okay. First thing I'm gonna do, we should subtract the constant over.
C.
Yeah, we're gonna subtract c this side. Because that doesn't have an x value, so we're just gonna shift it on over. Okay. So most of the times, like right at this point, we'd write the spaces or blanks on both sides so that we can find the c value doing whoever said the fraction and squaring piece. But sometimes we have that number in front of x squared, and I can't have that number there, so we typically factor it out. So that's what we're going to do next, is factor out the a on the left side. So if I take an a out of ax squared, what's left over? X squared. So that one makes sense, we're like dividing a out. But then my next term, dx, doesn't have an a value that I can just like easily take out.
So just, it's parentheses after.
We still have to take it out though. Yeah. So when you were factoring, that's basically a fancy way of saying we're dividing it out. So I'm going to divide the a together. So that way I can take it out, basically.
No,
just
just
over
get it over so you're not rummaging.
Okay. So then I'm going to leave my slots, my blank, in the parentheses. And I still have negative c on the right side with my blank on this side. So now we have it set up to complete the square. We find the c value. And how do we typically find the c value?
B over B divided by 2 squared.
And in our case, what is the b value?
B over I.
So we have b over a over 2 squared. So I don't like a fraction in a fraction. That's just like, it looks messy and it looks crazy. So to move the 2 out of like the lowest denominator, we can multiply by the reciprocal. So it's the reciprocal of 2.
Or 1.
1 over 2, so I'm going to multiply half to the bottom and half to the top. So then I'm multiplying b over a times 1 over 2, it's hard to see. But b times 1 multiplying straight across is b. And then a times 2 is 2a. And then squared. So that's just simplifying inside the parentheses. I still need to square everything inside to find the c.
Squared divided by 2.
Now I have to square the 2 as well, so it's 4a squared. Okay, so that's what's in the blank on the left side. On the right side, it's not quite that, since we factored out that a. So to fill in the blank on the right side, I need to make sure I multiply what's in my blank by the a outside the parentheses. So I'm going to add a times b squared over 4a squared. Right, this looks all confusing because we're working with all letters, no numbers. Yeah. Okay. From this point, we filled in the blank, we found the c value. Most of the times we factor the left side and combine like terms on the right side. We're typically able to add numbers on the right side. But these are all letters, so it's all kind of weird. But let's focus on the left side first. Let's factor it. So we know, since we created a perfect square trinomial, it's some quantity raised to the second power. Does anybody know what goes inside this parentheses?
Or b is e
b over 2a. Alright, so we're taking the fraction in the blank, we're square rooting everything. So square root of b squared is b, square root of 4 is 2, square root of a squared is a. Okay. On the right side, I would like to simplify this a little bit. Yeah, so I can write this as a over 1, and then multiply straight across.
We have AB squared.
Can that fraction be simplified? Okay, I can get rid of 20. So this cancels in the numerator. I can take the squared out, it's just a to the first power then, or just a. Okay, getting closer. So just to make this all look, because our goal is to get to the quadratic formula. Quadratic formula has one big long fraction. So on this right side, I would like to write this as one fraction instead of like 2 parts. So how do I add 2 things together? How do I add this right side? Gracie?
What?
How do I add the right side together?
Right. Can you just do C?
Okay.
That's what I was.
Yeah, I was like, whatever this month. Okay, but I can't add them together because,
Like they're opposite.
yeah, I don't have a common denominator. I need a common denominator.
Would be 4C.
Okay. So multiply 4 to top and bottom. I also need to multiply by something else. And an A. So the left side is just kind of chilling right now. Right. So since I have common denominators, I can add the numerators together. And I'm going to even flip it around so it matches what the quadratic formula is. So I'm going to write it as b squared then minus 4ac. Right, which that b squared minus 4ac is in the quadratic formula, so we are on the right track. Woo. So great. Okay. So let's try and get our x by itself. Yes, sir. We have examples after this. This is just proof.
Is this so we can solve the upcoming problems?
Will we have to work it out like this?
We're using the quadratic formula to solve quadratics. This
We
is
have
just
to
explain.
work it out like this? No. We're doing it to figure out
Yeah.
how to get them.
No, where it comes from. You're welcome.
Just
I knew you guys were curious to know where it came from.
I'm gonna just do that.
The origin story is the
Ah. Okay. So on the left side, if I was trying to get x by itself, what should I like move over or get rid of?
The PAs. B over 2A.
Well, b over 2a is in the
I guess
parentheses.
it's square root, or the square.
Yeah, so I want to get rid of the square to square root, but I need to do one thing before I do that part.
Right here.
I need to get rid of the a in front of everything. So technically we would divide, since I have a fraction on the right side, I always just like to multiply by the reciprocal, which is the same thing as dividing. It's just writing it a different way. So the left side, these a's cancel. Perfect. On the right side, multiplying the numerator by 1 doesn't do anything.
How are these people who do this one?
Multiplying the denominator becomes 4, root of a squared. Well, there is a cubic formula. Right, so this is solving a quadratic to the second power. There's a formula to solve a third degree power. Can you imagine how you would solve that
How
one?
can we even figure this out?
Completing the square. That's where the usefulness of completing the square comes
I go to before they figure all this stuff out. How they do it. Okay, these numbers will do.
from. Now you can just guess and check until you find one that works. And you're like, yay. Got one?
Yay, maybe complete after the case.
Okay, so now we're going to do what Gracie said. Get rid of squared by square rooting. So square root everything. So on the right side, I'm actually going to break the radical so it's over the numerator and over the denominator. Right, there's that quotient rule. And technically, when we square root both sides, we have a plus or minus happening. Almost there. So exciting. So the right side I can simplify a little bit. So the square root of b squared minus 4ac can't be simplified. That's in the quadratic formula. I don't even mess with it. Okay? But my denominator, I can square root 4 and I can square root a squared. So if I square root the denominator, what do I get? 2a. Yeah, my grade wasn't even.
For some reason, I already had
Okay. X is almost by itself. That was our goal. So we can subtract b over j a to the right side. Beautiful, right? So x is by itself. Just to finish it out, the quadratic formula doesn't have two fractions. They put this all together. And we already have common denominators. Lovely. So I can write this as one fraction, negative b plus or minus square root of b squared minus 4ac all over 2a. Bam! Prove the quadratic formula. Crushed it. So that's where it comes from. Manipulating the quadratic in general form to get down to this solving for x. Yeah. Just like I said, you won't have to regurgitate and do this again. But it is kind of interesting to know how to do it. Where it comes from. Friends like, I disagree. Very strongly. Okay, so let's actually use this and see how awesome it is. So if I'm going to solve it using quadratic formula, it needs to be equal to 0. So I need to rewrite this quadratic. Okay. Subtract from both sides. So here's my lovely quadratic. I can identify the a value, b value, and c value. What is a, b, c? Maybe in 0 is numbers, so the number of x squared is 1. Okay, so I'm going to plug in all these numbers into the quadratic formula.
X equals
So we like
negative
negative
5
negative
plus minus square root of negative 5 squared minus 4 times 1 times negative 4. Or 2 times 1.
right? So every letter in the quadratic formula is being replaced with -1, or +1, -5, and -4. So once you have it in this form, we just need to kind of do order of operations to simplify this down. So order of operations says do exponents first.
25.
And then I'm going to write this as positive 5, so negative is positive. I have 25. Then I could write minus 4 times 1 times negative 4 if I wanted to. Over 2 times 1. Order of operations says we're multiplying x. So I can multiply negative 4, positive 1, and negative 4 underneath the radical. 25 plus 16. And then 2 times 1 in the denominator. 2.
25 is 16.
Anybody know what 25 plus 16 is?
41.
41. So the trick is, can the square root of 41 be simplified? No, 41 is prime, so I can't like take out a perfect square. And it's not negative, but I need to take out a matching number. So we're going to leave our answers just like this. Is that right? Not too shabby. Okay, where do you want to start with this one? Balin says distribute. So what do we get out when we distribute?
6 minus 6
Okay.
equals subtract your x2 right?
Yep, that's fine. And I don't have any like terms on the right side, so it's just negative x squared plus 6x minus 10. Yeah, so either you can subtract x squared to both sides, or you can subtract 6x and add the 10 to both sides. Technically, it doesn't matter. But it's equal to 0, so I know I could use quadratic formula. So what does it even mean?
Negative 1, 6.
Okay. So plugging it into the quadratic formula.
Negative, oh yeah, negative 6 plus or minus 6 squared minus 4 times 1 times
You wrote down negative 1, right?
yeah, negative 1 times 2, or over 2 times negative 1.
All right, Rain, what do you want to do next? Do what? Okay. Like what? Sure.
Squared times negative 4, and then over negative 2, and then we put the 4 together,
Oh.
negative 40, and 6 squared, and
Well, what is 6 squared? Can you simplify that?
oh, and it'll be 36, right?
Yeah.
Minus 40. And that would be 4,
36 minus 40 is
negative
negative 4. Okay, so everything's simplified underneath the radical. So I need to simplify the square root of -4. So the square root of 4 is 2, but technically I can't square root negative numbers. Yeah.
So, isn't it already simplified? Oh wait, can't you do, why are you do
Because the square root of 4 is 2. The square root of -1 is 5.
I like we just like
Like the imaginary number I that we learned a couple weeks ago.
so they just were like we don't have a number so let's just put I.
Negative.
Well, you can't square root negative numbers, so we need
That's
something to
all
represent it. Technically, it doesn't work.
You know.
That's what I thought you were gonna put like a square root of 2 and square root of negative. No, you can't do that. Technically.
Okay, so then this is almost done. So I can divide everything by -2. So like -6 divided by -2 is 3. And then 2i divided by -2. Yes, technically it's negative I, but since I have plus or minus in front of there, we have both signs in the so it doesn't really do anything.
Yeah, I'll show you.
Oh, that's so sad.
Here's the thing. Okay,
Here's the thing.
I'm going to learn this. I'm going to take a test on it, and then I'm going to forget it.
That would be a mistake.
Why?
No, because the quadratic formula sneaks up on you every so often.
Like
When we start graphing cubics and doing rational functions. And
Okay. maybe that's forward. The year is 2025. Right?
We're in 2020, huh?
Right.
So
I know.
we're gonna do the discriminant.
But here's 2025. Am I going to use this still?
Mm-hmm.
No.
Why do you
I don't think a president used to be doing that.
I know.
Yeah, that's why he has a team for that.
Okay. So the discriminant is b squared minus 4ac. Where does this even come from? B squared minus 4ac. Because it should look familiar.
It's in the,
Yeah, it's in the quadratic formula underneath the square root symbol. Okay? So we can evaluate this little expression to figure out if I have two solutions, one solution, or two imaginary solutions. Okay. So if the expression is greater than 0, crazy. So basically I'm saying I have a positive number underneath the square root symbol in the quadratic formula. How many answers for x should I get?
2.
2.
All right.
Yeah, 2 real solutions.
Zero would probably.
Yeah. So if we think of this graphically, by 2 real solutions, basically a solution is x-intercepts. So my parabola, if I graphed it, would cross the x-axis twice. That's one case. Second case, what if the discriminant is equal to 0? How many solutions do we have?
No.
So technically, if I was thinking in the quadratic formula, I'm plus or minus the square root of 0.
that's your one.
That's one solution because I'm not adding or subtracting anything. It's just the fraction. There's one real solution. And if I want to think about it, visually speaking, I could graph the quadratic. One solution means I have one x-intercept. So it's literally sitting on the x-axis. And the third case, this expression could be less than 0. So basically the number underneath the radical sign is a negative. So what kind of solution did we get out? Well, yeah, that was the no solution because I can't take the square root of the negative. But on our last example, what did we have? Our last example was -4. And we got out this. So we have two imaginary solutions. So two imaginary solutions, I can't graph imaginary solutions when we're graphing parabolas. So basically I'm saying I don't have any x-intercepts. I'm not crossing the x-axis. Okay. So this is sometimes helpful to actually know. So ready?
No, that should be all.
Okay. So we're just gonna find the discriminant and then figure out if I have two solutions, one solution, and two imaginary solutions based on which case I'm in. So how do I find the discriminant?
Get your B. I don't know what A, B is.
So what is A, B, and C?
1, 10,
Then what's my formula for discriminant?
B squared minus 4.
Yeah, so then I'm just replacing A, B, and C into this thing. So I have 10 squared minus 4 times 1 times 23. So simplify it. Do order of operations, 10 squared is
Minus 23.
yeah, which is something.
92.
Okay.
Equal 8, which is greater than 0.
Yeah, so my discriminant is 8. Greater than 0 means how many solutions? 2 real solutions. That was it. So this is the answer for that lovely thing. We have one more thing.
Wait, can you go back up?
Okay. So quadratics we can always do launched objects, so I can throw a football, the football's in the path of a parabola. I can shoot a basketball, it's in the path of a parabola. Okay, so there's a specific formula that represents like a thrown object. So if we're throwing an object off the building or wherever we're at, our formula looks like this.
Do we have a 480?
Nope. Okay, so this should look familiar. We've used that -16 before. -16 is the force of gravity in feet per second. B naught is nu. and it is a 0 like subscript. This is the initial velocity. So whatever the force is that I throw the football or shoot the basketball or whatever gives me the velocity. H naught is the initial height. So how far from the ground I am when I throw the ball, or shoot the basketball, or throw it off the building, or whatever. Initial height. Then H is height at time t. So we use this often, and we'll use it when we do a project over quadratics in a couple weeks. So we should know how this works and how to use it. In 3 weeks, yes. In 2 weeks, no.
No, it's too easy.
Is everything gonna be crunched down for like the last day?
No.
They go practice it.
Teachers are now to give overload physics play.
Because the end of the semester.
I feel like I probably
Yeah,
could.
they can.
Yeah, if I wanted to, I could.
But you wouldn't want to do that.
I don't know.
No, because they're great.
That would be great. I want to get back so you can back in.
Don't you have like 2 days to get back and that?
I don't know. They never tell us until it's like, oh, grades are due. Nice. That's not it. Okay. So a basketball player passes the ball to a teammate. The ball leaves the player's hand 5 feet above the ground and has initial vertical velocity of 55 feet per second. Teammate catches the ball when it returns to a height of 5 feet. How long is the ball in the air?
Figure that out.
We are going to figure it out. So,
Equals 5.
yeah, so my velocity is 55. It'd be nice to know the initial height.
It was 5 feet.
Yeah, I throw the ball when I'm 5 feet off the ground. So I have this lovely parabola equation. So the question is, how long is the ball in the air? So basically, I am solving for t. But I need to figure out the value of h. And the idea is what the value of h is.
5.
Yeah, because that's how high off the ground the second player is. So then I can replace 5 with h. So now I have a quadratic that I can solve since I have one variable. Okay, where do you want to start solving this
I
quadratic?
just realized this is plus.
That's in general form.
Do you want to
Sure. So subtract 5 of those sides, which is nice because that cancels both 5s. Okay. So now we're here. I would like to solve this for t. So solving in quadratics, we can factor square root method, complete the square quadratic formula. What?
Did you just pick one?
Yeah, and there's always like an easier one to solve. I probably want to complete the square because like why would you want to? Anyways.
Just do like these.
Yeah. So can't square root both sides because I have a t value. So either I can factor or do quadratic formula. So I would try factoring at least, because factoring is easier than quadratic formula. So what can I factor out of this? I can take t out. And what's left over when I pull the t out?
negative 16t plus 55.
So since we're equal to 0, we can apply the zero product property, set each of them equal to 0. So t equals 0, and I have negative 16t plus 55 equal to 0. So this one, don't really want, because that's my initial height to begin with. But I can solve this other one.
Minus 55.
And then
Divided by negative.
And then assuming it's seconds. So when I pass the box ball to my TV, it's in the air 3.4 seconds. Sweet. Okay. Lots of notes today. Wasn't that fun? Good thing we started with the proof. Got my mind on the right track here.
Build the whole process.
Yeah. Everybody's so excited about that.